This is number 17 from section 7.3. It says to use the shell method about the x-axis for y equals 1 over x. And it gives us the graph as well, which I'll draw for you. Keep in mind, though, that if we solve for x, we're going to have or x equals 1 over y. So let's look at the graph. Oops, just give me 1 second. Okay, so I'm going to move up, and the graph looks like this. We have 1 over x, looks a little bit like that, and we're just drawing that part because we're going from 1 to 2. And so we're bound by the graph, the x-axis, and the vertical lines, x equals 1 and x equals 2. The ordered pairs here then are going to be 2 1/2, and up here it's going to be 1 1, or it is 1 1. Okay, so here's the issue. We want to draw a representative rectangle, and because we're doing the shell method, it has to be parallel to the axis of revolution. And here's the axis of revolution, that's our x-axis. So when we draw a representative rectangle, it has to be horizontal like the x-axis. So that's all great, but it's not representing the whole region. Because if we draw a different representative rectangle, maybe up here, you can see that the right and left are different than the lower rectangle. So what we need to do here, because we're forced to use the shell method, is we need to break this up into 2 regions. So we're going to break it right here. And my graph's not great, I know, but hopefully you're understanding what's going on. So one region is going to be this region below that line. And the other region is going to be this region above that line. So then we have our setup is going to be 2 different integrals and we're going to be using the y values because we're in terms of y. So notice that we have delta y, and that means we're going to use the y points for our limits of integration from the points of intersection. Our integral is then going to be from 0 to 1/2. That will give us the lower red chunk of area. Plus we're going to have the integral picking up at 1/2 and going to 1 for the upper chunk of area. Moving up. We're trying to move up. There we go. And get us to move up a little bit more. There we go. Alright, so now we have volume equals 2 pi. Integral from c to d of p of x, p of y, h of y, dy. And in both cases, because we're going about a coordinate axis, our p of y is just the variable y. And because, again, we're going about the coordinate axis, our h of y is going to be the right minus left. And notice again that in both cases the left is the same. It's going to be the x equals 1, but the right's going to be different. For the lower part, it's going to be x equals 2. Let me show you on the graph. So here, for the lower part, the right edge of that rectangle is bound by the line x equals 2. For the upper part, the right part of that rectangle is x equals 1 over y. So that then gives us volume equals 2 pi. Integral from 0 to 1/2 of y, which is part of the formula. And then our right minus left is 2 minus 1 dy. And then we'll add the other integral for the upper chunk of area. And that integral is 2 pi integral from 1/2 to 1 of y. And then our right minus left is 1 over y minus 1 dy. And so for each of these, we're going to simplify before we integrate. Notice here, you're just going to have 1 inside the parentheses from the first integral. So you're just going to be integrating 1y, which is y. And then the second integral will be distributing. So we'll get 1 minus y for the second integral from distributing. So 2 pi. Integral from 0 to 1/2 of y dy plus 2 pi. Integral from 1/2 to 1 of 1 minus y dy. And now we're ready to integrate. And that's going to be, let me move up again. I'm going to move way, way, way up now. Kind of get everything out of the way here. So we'll have 2 pi y squared over 2 evaluated from 0 to 1/2 plus 2 pi times y minus y squared over 2 evaluated from 1/2 to 1. And for the first integral, before we plug in the upper minus lower, we can cancel out those 2's, which will make it a little bit easier. So we're going to have pi times 1/2 squared, which is pi over 4. Lovely. And for our second integral, we'll have longer, 2 pi. Let me write small here. And it's going to be 1 minus 1 squared over 2 minus, upper minus lower, 1/2 minus 1/2 squared over 2. Close the parentheses and close the bracket. So that's going to be 2 pi. 1 minus 1/2 is 1/2. And then we have 1/2, and 1/4 divided by 2 is 1/8. Getting there, getting there, getting there. And so let's see, we're going to have pi over 4 plus 2 pi. And that's going to be 1/2 minus, and this is 4/8 minus 1/8, which is 3/8. And that's going to be, again, working in the brackets here, 1/2 is 4/8 minus 3/8. And let me move everything up again. That worked pretty good. And so we get pi over 4 plus 2 pi times 1/8. We can reduce the 2 and the 8, answer is then pi over 4 plus pi over 4, which turns out to be 1/2. Perfect. Times pi. So that would actually be pi over 2, not 1/2. 1/2 pi.